All right, ladies and gentlemen, let's take a look. We're going to take a look at the area of triangles. Once again, this is probably something you're familiar with. And so this should be a rather quick discussion. So let's take a look. We have the height of a triangle. It is the perpendicular segment from the vertex to the opposite side. So that means we need to look for a 90-degree angle. Okay? Sometimes it's going to be inside the triangle. Sometimes it will be outside the triangle. And so then we also need to talk about the base, because we're going to do base times height. The base is just the opposite side from that height. So the base and height basically intersect each other. So let's take a look. So the area of a triangle is 1/2 the product of a base and its corresponding height. Let's erase this and make sure you guys see the SE. So we have a base and a height, and then here's that 90-degree angle. And so the symbol for that, we have 1/2. Product means we times base and height. So the following question, the follow-up is compare and contrast area of a triangle with area of a rectangle. Just remember that that is base times height. So how are they alike? They both use base and height. How are they different? Well, the triangle is half the base and height. And why is that? Well, if we think back to how we found the number of degrees inside of a rectangle, if we picked a vertex and drew in the diagonal, we created two triangles. So a triangle is half of a rectangle. That's where 1/2 base times height comes from. All right, so let's find the area of a triangle. We've got a right triangle here. So when we look, here's our 90-degree angle, the two sides, the two segments that intersect, the two dimensions. So we're going to use 10 for the base, and we're going to use 6 for height. So we're going to use our formula, 1/2 base times height. So 1/2, 10 times 6. I usually do 10 times 6 and get 60, and then take 1/2 of that. Sometimes we're going to get fractions or decimals when we multiply by 1/2. And I like to multiply by fractions just one time. So if I multiply these two whole numbers together, I'm going to get another whole number, and then half of that. So we get 30 square centimeters. In this lesson, for some reason, they're using the written word. Remember, we can write that as 30 centimeters squared. Now what we need to do is find area of triangles that aren't right triangles. So if we notice now, this height is inside the triangle because there's our 90-degree angle. This height, I often see them shown with dashed lines, is outside, but there's our 90-degree angle. So for A, we're going to use 8 for the base. Oops. Substitute 8 for B and 6 for H. So we have 1/2, 8 times 6. 8 times 6 is 48, and 1/2 of 48 is 24. Our units were feet, so it should be feet square or square feet. I left that off and just wrote it with our abbreviation. For the next one, we have a base of 12, and we have a height of 6, that perpendicular segment. So it's going to be 1/2, 12 times 6. 12 times 6 is 72, and 1/2 of 72 is 36. These were in meters, so meters square. Not too bad. So ladies and gentlemen, you are going to do now for these 3 checkpoints, and then we will check in class. CIC. All right, now what we want to do is find the height of a triangle. And the thing about finding the height of a triangle it doesn't matter whether we're finding height or base, we're going to use the same idea. So what I know is that I have 39 square inches inside this triangle. I know that the base is 13 inches because here's that perpendicular segment. And I'm looking for the height. So we start off with our formula for area. We're going to substitute 39 for the area, because that's what the area was, and we're going to substitute 13 for the base. The first thing you're going to do, ladies and gentlemen, is get rid of your fractions. We're going to multiply by 2, and that's to get rid of 1/2. So I'm going to multiply by 2. That cancels that out. Multiply by 2 there, and I'm going to have 78 is equal to 13h. We're going to divide each side by 13. All right? And so when we do 78 divided by 13, we get 6 for our h value. We need to make sure we have a label with that. So the height of our triangle is 6 inches. All right? But this, to me, let's see if I can find my highlighter. This right here, multiplying by 2 to get rid of the 1/2, is our most important step there, so that then we're just into base times height, so you're down to your division. All right, we are going to work on this in class. This will be our warm-up. All right, so if you do now, do it in pencil, but we'll put this up on the board for your warm-up on Friday. All right, so we want to find the missing measurement. I can see that I'm looking for the height. So I have an area of 90. So I have A equals 1/2 times B times H. So plug in what I know. I know I have an area of 90. I have 1/2. My base is 20. And I need to solve for H. Remember our first step, times by 2 to cancel out 1/2. 2 times 1/2 is just 1. So it cancels it out. 2 times 90 is 180. I have 20 times H here. We're going to divide by 20. And so I get, not 90, let me do some better math. 9 is equal to our height. And so because this is in meters, I have 9 meters for my final answer. Here we have a base of 6, or I'm sorry, a base of B. Here's my 90-degree angle, and so here's my height of 16. And here we have a base of 8. So what I want you guys to do is to do now, and we will check in class. All right, one last example to go through, and then we have a theorem we're going to take a look at. We need to find the ratio of the areas of the similar triangles and then find the scale factor. So we're going to go through and look at triangle ABC. So that's 1/2, 2 times 4, 1/2 times 8 is 4 units squared. DF is 1/2 base times height. So 1/2 of 18 is 9 units squared. So I need to look at the ratio of those areas, and the ratio of those areas is 4/9. That doesn't simplify at all. What I now need to do is look at the scale factor. That was part B. So the scale factor, if we look at this, we have BA to ED, so we have 2/3. That doesn't simplify. And then we have 4/6. 4/6 is equal to 2/3. So we do see the scale factor is 2/3. So I need to look at the ratio of the areas and how it's compared to the scale factor. It is the square of the scale factor. So what does that mean? Well, if I look at my scale factor, 2/3, if you square 2, that means you're doing 2 times 2, which is 4, showing up here. And then we have 3 times 3 for being squared, and that's 9. So because area is squared, our ratio now, when we take a look at the areas, is going to be squared. So I can find a scale factor given the ratio of the areas by taking the square root of both of those. Or I can find the ratio of the areas by squaring the scale factor. And so that's our theorem here. That if you have two similar polygons, whether they're rectangles, trapezoids, squares, we're going to look at hexagons, pentagons. If the polygons are similar and they have a scale factor of AB, then the ratio of their areas is A squared over B squared. So what does that look like in symbols? If they have a scale factor of A over B, then the area of ABCD is over the area of EFGH is equal to A squared over B squared. And so we'll take a look at those types of problems with some examples in your book and talk about those a little bit more in class. We'll see you guys tomorrow.